Welcome everybody to Let's Talk About Static Routing. I would typically have a picture-in-picture of me talking to you, but my allergies have been really bad lately and I don't look that good or well, so I'm going to bypass that today. But I just wanted to cover the concept of static routing. Remember, this is a big concept, big chapter, so what I'm covering today is going to be a quick overview of what it is. So please read the curriculum and do some more research on it to get more detail. So let's start. Okay, so we'll cover static routing advantages and configuration and default routes depending on IPv4, IPv6. They're kind of the same when it comes to programming, as you know from earlier programming the interfaces of the given types of IP addressing. And of course, troubleshooting. Troubleshooting, you always use a show command and check to make sure all the numbers match and connectivity is working or not working and figure out why it's not. First thing, implement static routes. Okay, what's the purpose of static routes? Static routes will connect two devices or two networks or two entities together using a direct connection where dynamically they will learn the routes using whatever routing protocol you may be using, router RIP2, OSPF, egrep. So there are advantages and also disadvantages of using static routes over dynamic routes. Oh, and here's my issue. Here's my point. Why static routes? Dynamic routes are generally independent of size, increase in network size, because you're going from point A to point B and not having to use the resources of finding all the other devices within your given thing. Dynamic routes are less secure. Statics are more secure. I don't go either way with that, because if you have a static route, it's always going to be the same route regardless of where you're going. So that's an issue that I have, but that just happens to be what is happening in today's networking world. And this is, if you ever hear the term stub network, that just means you have one router outside of your organization. So in this case, you would actually have a stub router going out to the network, and then you could just have a direct static route to where you're going to the other router. Since you would only have one router, you don't have to worry about routing tables or traffic or anything like that besides what's in your given organization. Why would you use it? To connect to certain networks, connect to stub router. Like I said, it's just one. It helps you summarize routing tables and also create backup routes in case something happens with primary. So what you could do is you could have your dynamic route going, and if something happens, you can have your static route be the backup for that, and you can have a static route be wide open to everything, which is kind of ironic, since it's primarily for a direct connection. And here's just an example. You configure it to go from here to here, and it will reach anything within the given network that is shown on here. So from here to here, you're using your 172.16.3.0.24, and then apparently this one's using the same network, so you would just connect right to it and not have to worry about searching for other networks. Dynamic routes can use 00000. Remember, these are wildcard settings, which means it can be any IP address, any subnet, on a given IPv4 address. You can also choose the gateway of last resort, which would be your last address going out of your network to your chosen network or internet or cloud. Summarization. This is, as I mentioned before, if you have a Class A, Class B, Class C, Class A by default has to have a minimum of a /8 number. Class Bs have to have a minimum of a class 16, or 16, and a class C 24. What summarization addresses do is they create one address that will encompass all of these within a given subnet address. So, and also too, it only makes one address. It only makes one. It only makes one network from here to here. So all of these networks are represented by this one. And if you look at my summary addressing video on my YouTube channel, you'll see how that's done. It's pretty reasonable, easy to do. And it comes from the old phone system where they had to do summary addressing, or they had to do summarizations, because otherwise you would have everybody would have their own phone line coming from their house to the phone company. But because of summarization, they can take multiple lines, multiple areas, and combine them into one. And then at the end, it would expand it out to the other ones that are on there. So please watch my video on summary addressing, and that would explain to you how this works in more detail. Floating static routes are just basically, they can float from point A to point B depending on how you want to do it, which direction is the best way to go, what path is the best way to go, and it would also do it on the trustworthiness of the primary route, if it's good or bad, and also to what the administrative distance is. Because remember, the lower the administrative distance, the chances are it's going to go that direction. Unless it can't do it, then it will fluctuate to the other one, even though it's higher. 2.2, configuring static routes and default routes. Okay, just like before, you have to make sure you're in the config T or config prompt here, and you type in your address, your subnet, and you can either type in the where you're going to address, or the interface you're leaving from address, or it's not address but port number. Here's some examples. You're going to go from this port, you're going to go to this address and that address. So if you look at the pathing, you can actually see it going through its various hops to each of the other networks. So just kind of look at the table, and you can actually visualize it. I would explain it to you in more detail, but it's easier just to see where it's going. Remember that this is point 2 of the address, point 2 of this address, point 1 of this address, point 1 of this address. And that's something that's hard to comprehend if you don't know how to read these maps, and that's what I'm explaining to you right now. And then, of course, here's another example of it. You can ping it, and it will show you that it's going to go from here to here, which is showing you pinging. And here's another one where you can ping. It doesn't look like it worked, but it should have worked. But all you're doing here is you're just checking your connectivity from your source router to your destination source. Okay, here's how you would program what you just saw. Is you would type in, we're going to go from 172.16.2.1 to 170.16.2.2. Remember how I said these are the numbers here. Then it's going to go from 191, this network, to this here, and then from this network. Remember, anytime you see zeros or any kind of number that is actually divisible by the subnet, it is a network. So this network is going to this address. This network is going to this address. This network is going to this address. And if you need more clarification on that, please look at my summary, my subnetting C or B videos that I also have posted on my YouTube channel, and that will help you get a better understanding of what this is. And this is another example of when you do a show IP, and remember the piping command I told you, that's above the enter key, shift, and it will show you that Sorry. Some people pay Candy Crush. So anyways, this is just an example of how you can go from point A, point B, point B on it. And you can make it recursive, which means it would do it over and over again. Here's just another example of how you would do a direct route. When you program all this in, here's the route it takes, the ports it goes out of, and then here's where it goes to get to the final destination it's going to. And then, of course, we have Cisco Express Forwarding. This is something that's on the newer, well, not newer routers, but current routers and anything that are 12 and above. Right now, they're at 15.3, I believe. And this is just another way of doing the same thing using their type of next hop addressing. And to verify it, you would just show the route, and then it should tell you how it's going to get there and what the next hop destination is going to be. And if you do this configuration here, it will show you the hops throughout the whole entire thing. Okay, here is what I mentioned earlier about. This is one that is a wildcard, which means it can be any address, any subnet mask going to any address, anything. So this is kind of like your stub router going out to anybody or whatever you want to do. You would use this as your gateway of last resort, just to get out of your organization. And here is how you program it. I'm going to go from any IP address in my network to my subnet to this particular one, which is right here. So you're going from anybody here to point 2 here. And then, of course, remember, I always tell you, use the show command. And if you don't know what comes next, you show question mark, and it will show you what's happening. Pay attention to the ledge here, and it will tell you what's happening and who's going to what, and you have administrative distance and so forth. Okay, this is one of the packet traces you can do that's in the curriculum, and here's a live lab that you can do. And this is where you would actually plug in the physical cable. Remember, all your loopbacks, you can either program a loopback, or you can plug in a little RJ45 connector that will make it a loopback on the given device. So depending on your classroom and settings, check to see either one. IPv6, same kind of format, prefix, length, except for you won't have a subnet mask here, address and existing interface. Unicast routing, like I said, that just happens to be, unicast means it's only going to go to one location, which is going to be here. Unicast is singular, so it's point A, point B. And then, of course, you can ping it to make sure it works, and you can see the routes, and you can follow the traffic. Remember, if you can't follow it to the end, then you know something is wrong with basic configuration. So you'd have to go back and actually do a show run to verify that your paths are correct, or you're using the right ports to go out of. And then here's some more information about IPv6. Only the next hop IPv6 is specified. Only the router exit is specified. So here, this is kind of like IPv4, where you can specify either the address or the port to the next, either where you're going or where you're coming out of. Then here's another show IP route, and it just shows you the routes, your administrative distance, connection type. You know, are you directly connected, locally connected? Excuse me. Then here's some other, just when you type in the routes, here's your route, your next one going out, and you're going out the port. So these are just other ways of programming the exact same thing you did in IPv4. Here's another way of doing a local link, where you're going from point A, point B. Some more show command static, and it will show you the static routes. And S means they're static. So if You program static, and if you don't see S's over here, that means something is wrong, and you did not program static. You programmed something else, like maybe connected or RIP or any other thing of that nature. This is the other one, like I mentioned before. This is the one that remember loopbacks are these numbers here, like colon slash 1 0. These are different ways that you can loop back depending on what you may be doing with your IP address and what address you're going out of and what interface you're going out of. Here's another way you can program it. Here's somewhere IPv6 how to ping IPv6. You don't have to put the slash number on an IPv6 ping. Here's a lab that you can do within Packet Tracer, and of course you have the live lab. These two labs are pretty much identical to the IPv4s, except for now you're just typing in IPv6 addresses instead of 4s. Remember that typically if you see a 2001 type address, it's a private, and a FEFC number is a public address between devices. When you're looking for information on the route, remember that you also need to pay attention to the administrative distance. So egrip is 90, igrip is 100, OSPF 110, ISIS 115, RIP 120. And by default, a static route is 1 because it's the most closest, fastest direct path. Higher the number, slower the connection, even though in computer terms that's not much, but it's still an indication of what kind of connection you're using. This is also good to know when it comes to taking tests, CCNA, and those type of things. Also Network Plus, A+, those all include these as questions. Here's some more show commands you can do. If you type in the thing in here, then your administration, your admin distance is going to be 1 because you're doing a static route. Floating static route, you can do trace routes. Trace routes are better than pings. So remember, all pings do is just verify that the other side is there. Trace routes will actually make sure that the connection is there. Here's some more examples of trace routes that you can do and verify the path between one router to another or another connection. Here's IPv6 routes. And here's one that you can configure floating static routes if you need to. Here's some more we can automatically install host routes. These are just other ways that you can program your IPv4 or IPv6s to do other type of functions. Here's some more static host routes. Troubleshooting, like I said, just make sure your ports match, your subnets match, your networks match, and that you're going through the right interface on your thing. That's typically the problem, is you put in the wrong subnet mask or the wrong port that you do. Same thing here, just verify. Troubleshooting is probably what you're going to be doing most of the time. All you're going to do is make sure that everything you're connected to is either the same prototype, subnet, or network, or segment. Anything outside of that is going to cause issues. Cabling also is another big issue. Also, I tell my students all the time, make sure you see lights on your devices. You should always have some kind of light device. If you don't have a light between two routers, chances are the other side is not programmed. If you see yellow lights, connected, not configured. Green lights, good, not necessarily. Ping, trace route, tracer T command. Here's some more information about check your stat, check your forwarding, You can even do a ping command and you can send traffic through a static route. Do multiple pings, and also too, you can also do this. I would typically do this on an off hours, so you're not interfering with the company's time or business process throughout the day. And like I mentioned before, here are your troubleshooting commands: ping, trace route, show IP route, show interface brief, show CDP neighborhood details. Show CDP is, you need to be careful because you need to make sure that all devices are Cisco based devices. They have other commands that will also do it at the same time. For security purposes, always turn off CDP neighbors. So if anybody snoops your system, they can't see your whole mapping of your device system. Trace route is at the terminal interface. Tracer T is at the DOS prompt. And of course, if you have Linux, you're going to have different commands, but just be aware that you can do the same things regardless of what you're doing. Here's some other ones that will tell you that if you are missing routes, if they're down, protocols are down, if something's wrong, just go through and look. And like I said, typically this is just some common sense thing about saying, well, I can go, honestly, ping from point A to point A, point A to point A. Ping the next step or next hop. Don't try to ping all the way to the end. Because if you ping all the way to the end, if you get an error, you won't know where it's happening. So if you progressively ping, you will find out what's happening towards the end. Trace route will also help out tremendously. Here's some other commands you can do. Select, or you can do section IP routes. Here's some troubleshooting labs that are included within the curriculum. Here's a live lab you can do. So if you have real equipment, you can actually run this in your real lab and actually see what happens in real time, real devices. And 2.4 chapter summary. Explain the routes and routing from the aspect of static routing for both IP and V6. Configure, troubleshoot. And like I said, I kind of went through this pretty quickly, but this is just like a quick overview of what you should do or help you do for it. I know this is the complex chapter, so please read up on it. And like, I apologize, I usually have picture-in-picture, but right now my allergies are really bad and I'm just not all together. So take care, and please come back for my Let's Talk About video, and remember to check out my other ones, and everybody have a good day and take care. Thanks.